So now we are going to discuss in this session about equation of motion of single degree of freedom, free damped vibrations. Three important terms that one should underline are single degree of freedom, free and damped vibrations. Up till now we were discussing about undamped vibrations. Equation of motion is mx double dot plus cx dot plus kx equal to 0. We have discussed all this in earlier session. I will just review it in 1 minute and then we will start with next point. Mx double dot plus cx dot plus kx equal to 0, that is acceleration force plus damping force plus spin force equal to 0. Here two new words are introduced. C, that is damping coefficient, is force divided by velocity, and critical damping coefficient, that is again damping coefficient, but it is critical damping coefficient. Its unit is Newton per second meter. A ratio of actual damping coefficient C to critical damping coefficient CC is called as zeta. Zeta is damping factor or damping ratio, which is unitless. It is ratio of actual damping coefficient and critical damping coefficient. Both are having same unit, Newton second per meter. Omega is natural frequency of free undamped vibrations. Fn is natural frequency in hertz of free undamped vibrations. It depends on stiffness and mass of the system. Time period Tp is reciprocal of natural frequency. 1 by Fn is Tp, or 2 pi into under root m by k. And omega d is again a new term, that is natural frequency of undamped vibrations into under root 1 minus zeta square. It is called as a damped natural frequency. This damped natural frequency is function of natural frequency of undamped vibrations and damping factor. If damping factor or damping ratio zeta is equal to 0, omega d is equal to omega n, it is as good as vibrations are undamped free vibrations, and natural frequencies of undamped free vibrations. If zeta is 0, if zeta is having some value, this particular term under root 1 minus zeta square will be a fraction. Therefore omega d is always fraction of omega n. Omega d is equal to omega n when system is free undamped vibrations. If system is free damped vibrations, omega d is always less than omega n. From these equations also it is proved. As I have communicated to you, let me just again appeal you to write down the formulas on your notebook. That will be better for you to understand it. We are going to discuss about number of equations in today's session. I advise you to write down those formulas as and when we go ahead, so that will help you to understand the things better. This is just for your information, that if it is now forced vibrations, for our syllabus we don't have forced vibrations, but if it's forced vibrations, then on the right side you will not see 0, but you will see f sine omega t. This is difference between free vibrations and forced vibrations. So this is single degree of freedom, damped, forced vibrations. This is single degree of freedom, undamped, forced vibrations. On the right side there is force, but there is no damping term. So it is single degree of freedom, undamped, forced vibrations. Torsional vibrations. Now torsional vibrations are those vibrations where the motion is about the axis. For longitudinal vibrations it is parallel to axis, up and down. For transverse or lateral vibrations it is perpendicular to axis, but for torsional vibrations it is about the axis. That is what we had discussed earlier. And one of the examples is when a shaft is rotating, and if that rotating shaft vibrates, its vibrations are termed as torsional vibrations, because shaft will twist and untwist, twisting and untwist. It will twist and untwist. So here, instead of linear displacement, it will be angular displacement theta. So x is replaced by theta. Instead of d square x by dt square, it is d square theta by dt square. Instead of mass, it will be moment of inertia I. And here, instead of linear stiffness of the spring, it will be torsional stiffness. So this is also K, but it is linear stiffness of the spring, but this is torsional stiffness of the shaft. So equation will be on the similar line. I d square theta by dt square plus k theta equal to 0 for undamped vibrations, and for damped single degree of freedom torsional vibrations it is I d square theta by dt square, actually it is dt, plus c d theta by dt plus k theta equal to 0. So this is with damping, this is without damping. This is torsional, these are all torsional vibrations. How it can be recognized or identified? Because there is I and theta in place of m and x. So d square, not d square x, it should be d square theta by dt square, that is theta double dot, and d theta by dt is theta dot. Now let us see equation of motion for single degree of freedom free vibrations is, let me again try to maximize it. Let me maximize it to the extent possible so that it will be easy for you to read it. Just a minute. So I have maximized it to the extent possible. You can see on the screen that this is damped free vibrations. This is stiffness K, damping coefficient C, mass M. This is displacement X, and accordingly velocity will be x dot and acceleration will be x double dot. These are the forces. Upward force is kx, cx dot. Downward force is mx double dot. Free body diagram shows that downward force is m into x double dot, accelerating force. Upward resisting forces are kx, cx dot. So equation as said earlier for undamped free longitudinal or lateral vibrations is mx double dot plus cx dot plus kx equal to 0. Same equation that I had told you earlier, I had derived earlier for single degree of freedom damped free vibrations. Free vibrations, so right side is 0, damped vibrations, so cx dot is present, and it is single degree of freedom system. Equation is mx double dot plus cx dot plus kx equal to 0. Now this equation, as you know, if you have studied mathematics earlier, then this is linear homogeneous equation. This is linear homogeneous second order differential equation. Linear homogeneous second order differential equation. M d square x by dt square plus c dx by dt plus kx equal to 0. Now for solution of such equation, we can assume this solution for x. Of course we have to solve the equation for x, so we assume the solution as x equal to e raised to st. Therefore x dot is s into e raised to st, x double dot is s square into e raised to st, right? So what I was saying is this is equation of motion for free undamped single degree of freedom, free damped single degree of freedom vibrations. Its solution is the solution that is applicable to linear or homogeneous second order differential equation. Solution assumed is x equal to e raised to st. Therefore x dot is equal to s into e raised to st. X double dot is equal to s square into e raised to st. X dot, x double dot. X is displacement, its first derivative, its second derivative. Now substitute x, x dot and x double dot into this equation, into equation 1. So they are substituted here. So it is m into s square e raised to st plus c into s into e raised to st plus k into e raised to st equal to 0. How this equation is obtained is very simple. You have substituted value for x, x dot and x double dot from equation 2 into basic equation for free damped single degree of freedom vibrations, that is into equation number 1. M into S square into e raised to st plus C into S into e raised to st plus K into e raised to st is equal to 0, where M is mass of the system, C is damping coefficient, K is stiffness, T is time. Right. Now let us take e raised to st common. If e raised to st is taken common, it is equal to e raised to st into bracket m s square plus cs plus k bracket complete is equal to 0. E raised to st can be taken towards right side, so it is 0 by e raised to st. So it is equal to m into s square plus cs plus k is equal to 0. Now you must have a question in your mind which let me answer. Here s is nothing but root of the equation. We have to solve this equation and we have to find roots of the equation. S is root of the equation. M is mass of the system. C is damping coefficient. K is stiffness. And S, small s, is root of the equation. Now, for this kind of equation, roots of the equation can be written as S. It will have two roots now. For this kind of equation, it will have two roots. S that is equal to S1, S2. S that is equal to S1, S2 is equal to minus C plus minus under root C square minus 4mk by 2a. Sorry, 2m. So it is nothing but, it is written as minus a plus minus under root b square minus 4ac divided by 2a. Roots of such equation can be written as S1, S2 is equal to minus b plus minus under root b square minus 4ac divided by 2a. So here in this equation, a is equal to m, b is equal to c. In this equation, a is equal to small m, b is equal to small c. Right? And c is equal to 1. A is equal to small m, b is equal to small c, and c is equal to 1, coefficient of k. So equation is written as S1, S2 equal to minus c plus minus under root c square minus 4mk divided by 2m. So it means S1 is equal to minus c by 2m. It is simplified, plus minus under root 1 by 2m into under root c square minus 4mk, and S2 is equal to minus c by 2m minus 1 by 2m under root c square minus 4mk. S1 is plus positive root and S2 is negative. So there are two roots. If plus sign is considered, you will get S1. If minus sign is considered, you will get S2. Now, these three roots can be of three types. Roots can be real and equal. Roots can be real and distinct. And roots can be complex roots. This is something which you had learned earlier in Mathematics 1. I guess in Mathematics 2 or Mathematics 3. How to solve linear homogeneous second order differential equations. That is something you have learned earlier and that is applied here in vibrations. Nothing different. But how, from where it has come? It has come from equation of motion for free single degree of freedom damped vibrations, and that equation is mx double dot plus cx dot plus kx equal to 0. This is linear homogeneous second order differential equation for which such a solution is assumed: x equal to e raised to st. Its first derivative x dot is taken, its second derivative x double dot is taken. Then these three values are substituted in equation 1. You will get equation ms square plus cs plus k equal to 0. For this equation, its root s, there are two roots rather, s1, s2, and those can be determined from standard equation minus b plus minus under root b square minus 4ac divided by 2a. But in this equation, a is small m, b is small c, and c is 1. So accordingly, if substituted, you will get S1 equal to minus C plus under root c square minus 4mk divided by 2m, and S2 as minus c minus under root c square minus 4mk divided by 2m. Now it is simplified by dividing 2m separately by c and to this root also. That is how S1, S2 can be written. Now it means that this equation has two roots, right? Now there are three situations. These two roots can be either equal and real, or roots can be real and distinct, or roots can be complex roots, right? Depending upon that, let us come back to this slide again afterwards. Depending upon that, the vibrations are called as underdamped vibrations or overdamped vibrations or critically damped vibrations. Damped free vibrations can be of three types: underdamped vibrations, overdamped vibrations, critically damped vibrations. Now, when it is called as underdamped vibrations, when it is called as critically damped vibrations, and when it is called as overdamped vibrations is clear in this particular slide. So as to connect this with earlier slide, I just want to tell you that it depends on value of zeta. Zeta is equal to 1, or zeta is less than 1, or zeta is greater than 1. And zeta is nothing but damping factor. Zeta is damping factor or damping ratio. It is equal to actual damping coefficient upon critical damping coefficient, right? And damping coefficient, as said earlier, is something which indicates damping capability of the system. If damping coefficient is having higher value, damping is better, right? Its unit is force upon velocity. Let me just correct it. I think I should correct it. Newton second per meter. Please correct it to Newton second per meter. Force divided by velocity. Force is Newton, velocity is meter per second, which again we had discussed in the morning session. So, underdamped system is one where damping factor is less than 1. Overdamped system is one where damping factor or damping ratio is greater than 1. And critically damped system is one where damping factor or damping ratio is equal to 1. Underdamped less than 1, overdamped more than 1, as the name indicates. Under less than 1, over greater than 1, and critically damped is equal to 1. And what is greater than 1, what is less than 1, what is equal to 1 is damping factor. So whether to call damped vibrations as underdamped vibrations or overdamped vibrations or critically damped vibrations depend on the types of roots of the equation and value of zeta. For underdamped vibrations, roots are complex. Overdamped vibrations, roots are real and distinct. Critically damped vibrations, roots are real and equal. Now, after introducing this, let me go back to this slide. Now, let us try to connect. What is zeta here? Now, let us go through this particular small derivation so that you will see that S1, S2 are written in terms of zeta here. S1, S2 are written in terms of zeta. How that is done? Right now, S1, S2 are in terms of C by 2m plus or minus 1 by 2m under root C square minus 4mk. But now, these same equations, these two equations, equation for S1, equation for S2. Equation for S1 is equation for first root, and equation for S2 is for second root. Difference between S1 and S2 equation is this sign. For S1, this sign is plus. For S2, this sign is minus. For S1 sign is positive, S2 sign is negative. Now it is simplified, and these equations are written in terms of zeta. How that is written? Let's see. This under root term c square minus 4mk is taken here. Under root term which is there under root c square minus 4mk, it is equal to 0. C square minus 4mk is equal to 0 for critical damping because zeta is equal to 1. For critical damping, C square minus 4mk is equal to 0. And for critical damping, C is equal to Cc. Actual damping coefficient is equal to critical damping coefficient. How? Let's see here. Critical damping, zeta is equal to 1. Zeta is equal to 1 means C is equal to Cc. Zeta is equal to 1 for critically damped system means C is equal to Cc. And for under damped system, C is less than Cc, zeta is less than 1. For over damped system, C is greater than Cc, zeta is greater than 1. So under damped system, zeta is less than 1, zeta is less than 1 means C is less than Cc. Actual damping coefficient is less than critical damping coefficient. Over damped system, zeta is greater than 1 means actual damping coefficient is greater than critical damping coefficient. And critical damping, zeta is equal to 1 means C is equal to Cc. Roots are complex, real and distinct, and real and equal respectively. Let us again go back. So for critical damping, C square minus 4mk is equal to 0, but C is equal to Cc. So let us put C equal to Cc. So Cc square minus 4mk is equal to 0. Therefore, let's take 4mk to right side. Cc is equal to under root 4mk. Cc चा root घेतला आपण. Cc is equal to under root 4mk. 4 is taken outside. So Cc is equal to 2 into under root km. Okay. So it is equal to 2m परत बाहेर घेतला आणि 8 divide केला is equal to 2m omega n. So let me show that on my slide. I have that here. This will be clear out here. Single degree of freedom, free damped vibrations for critical damping, C is equal to Cc. C square is minus 4mk is equal to 0. So C is equal to Cc. Therefore, Cc square minus 4mk is equal to 0. So Cc is equal to under root 4mk. So Cc is equal to 2 into under root mk. So Cc is equal to 2 into under root multiply and divide by m. m ने multiply केलाय and divide सुद्धा केलाय. So Cc is equal to 2 into under root m square into k by m. इक्वेशन तेच राहील, फक्त आपण m ने multiply आणि divide करतोय. So Cc is equal to 2 into under root m square into k by m. So Cc is equal to 2, m square will come out, that will become equal to m. So Cc is equal to 2 into m, and under root k by m is omega n. You should be very familiar with this now. Omega n, that is natural frequency of undamped vibrations, is equal to under root k by m. So under root k by m is omega n, m square when comes out is m, and 2. So Cc is equal to 2m omega n. Critical damping coefficient is equal to 2 times mass of the system into natural frequency of undamped vibrations. Right? So Cc is equal to 2m omega n. I have tried to explain it on a separate slide, how it is equal to, how C is equal to Cc, and how under root km into 2 is equal to Cc, or how Cc is equal to 2 into m into omega n. But we know that zeta is equal to C by Cc. So let us rearrange. C by m is just written as C by Cc into Cc by m multiplied and divided by Cc. This is just kind of rearrangement. Here also rearrangement is done, here also rearrangement is done. It is C by m only, but multiplied by C divided by multiplied by Cc divided by Cc, so as to get a different correlation. C by Cc is zeta, damping factor, and Cc by 2m is omega n. Cc by 2m is omega n. Why? Because Cc is equal to 2m omega n. So Cc by m is equal to 2 omega n. Let me show here. Cc is equal to 2m omega n. So Cc by m is equal to 2 into omega n. Cc is equal to 2 into mass into natural frequency in radians per second. So Cc, that is critical damping coefficient, divided by mass is equal to, इथं काय राहील, 2 into omega n. तेच आपण इकडे घेतले. मी तुम्हाला सेपरेट स्लाइड वर दाखवलं म्हणजे लगेच कळेल. म्हणजे what we can substitute C by CC as zeta and C by M as 2 zeta omega n. 2 omega n कुठून आला? CC by M आणि zeta कुठून आला? C by CC. परत एकदा सांगतो म्हणजे तुम्हाला लगेच समजेल. C by M आपण एक कोरिलेशन एस्टॅब्लिश करण्याचा प्रयत्न करतोय. C by M is equal to C by CC into CC by M. C by CC is zeta and CC by M is 2 into omega n. So C by M is 2 zeta omega n and K by M is omega n square because under root K by M is omega n. So K by M is omega n square. All this is substituted in these equations. In these equations, it is substituted. S is equal to minus C by 2m plus minus under root 1 by 2m into under root C square minus 4m cube. So C by 2m, just for example, to cross check, I can tell you. For cross check, just let me tell you. C by 2m is nothing but zeta omega n. C by 2m, 2 इकडे आणला. C by 2m म्हणजे zeta omega n. And then 1 by 2 into substituted for C square minus 4m. 2 zeta omega n is C by m and 4 omega n square for this term. For let us see this equation. S is equal to or S1 S2 is equal to minus C by 2m plus minus 1 by 2 C by m square minus 4k by m. आता C by m is 2 zeta omega n. K by m is omega n square and C by 2m is zeta omega n. Let me repeat again. Roots are written in this form of equation. S1 S2 is equal to minus C by 2m plus minus half under root C by m square minus 4k by m. Now let us see for each of the term it is substituted. C by 2m is C by 2m is zeta omega n. C by m is 2 zeta omega n and K by m is omega n square. So equation becomes S1 S2 is equal to minus zeta omega n plus minus half under root 2 zeta omega n bracket square minus 4 omega n square. If this is simplified, you will get it like S1 is equal to minus zeta plus under root zeta square minus 1 bracket complete omega n, and S2 only changes negative sign. S2 is equal to minus zeta minus under root zeta square minus 1 bracket complete omega n. I will give you 2 minutes time so as to read all these equations, try to understand how everything has come and try to write it down on the notebook. I will give you 2-3 minutes. Please do this. Because we have to be very clear with this, there are a number of concepts. I can see the chat box. Please write your questions in the chat box. Please try to understand all this. I have explained it a number of times. Write down all this on your notebook so that everything will be very clear to you, and write down your questions if any in the chat box. I think if maybe you will have to put in some efforts, but then screen is not bad. It is that way visible. Let me know if anyone else has problem. Someone is saying that screen is not that clearly available, but I have magnified it to the maximum possible extent. Maybe let us check if problem is at your end and try to write down everything. I am giving you next 2-3 minutes so that you can complete this exercise of writing down all the equations. Please write down all the equations one by one. Try to understand everything that is explained. Sorry. So write down everything. Let me know if there are any questions so that I can answer your questions. There are last 5 minutes. We will go ahead from this point tomorrow. And today again, we are going to start with another session. So in the next session, let us take it further today itself. And tomorrow, again, we will go ahead from that point onward. Right. So let's utilize these 3 minutes so as to understand this, and then we will immediately start next session. So I am giving you 2 minutes of this session so as to write down all these equations and understand, so that you can come with questions if any for the next session immediately, that we are going to start immediately. Okay, last 2 minutes, and then we will start with another session. For another session, as usual, use our regular ID and password 477. It starts with 477, and use regular password which is 188347. Okay, what I will do is I will share these notes on WhatsApp immediately, so that looking to that we can go ahead. We'll do that, no problem, no issue. I'll share it on WhatsApp. Just a minute. Give me 2 minutes in between. I will just share it.